Mathematics at Innit College, a YouTube channel for high school mathematics education. Mathematics 3C and Mathematics 4, Swedish high school education system. Miscellaneous problems on derivatives. Hi, this is Babak. In this video I'm going to solve the following problem for you. Let p of x be a quadratic polynomial, a polynomial of degree 2. Such that p of minus 2 is equal to minus 3, and for all non-zero real numbers x, we have p of x plus p of 1 over x equals to p of x multiplied by p of 1 over x. Determine p of 2 plus p prime of 2. I recommend you to pause the video at this point and try to solve the problem yourself. If you do everything correctly, the answer that you will get at the end should be equal to minus 7. Okay, now let us start solving the problem. It has mentioned that this p of x is a polynomial of second degree. So the most general polynomial of second degree, you know, is equal to p of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The reason that a cannot be equal to 0 because if a is equal to 0, then this term is gone, and then I am facing a first degree polynomial, which is not the case for this problem because it's mentioned that p of x is a quadratic polynomial. Okay, but now let us come here. P of x plus p of 1 over x. Of course, p of x is the same expression, but what p of 1 over x is? Okay, so p of 1 over x, it means that you need to go to your function, replace x everywhere with 1 over x. It's reciprocal, yes? So p of 1 over x, if I replace x with 1 over x, so let me write this in pair of brackets. So p1 1 over x becomes a, instead of x I put 1 over x, so it becomes a over x squared. Then again, instead of x I put 1 over x, it becomes b over x, and then I have a c. Okay, so that is my p of 1 over x. So let me call this relation, let me give it a name, star, and then I would do this. From star and these things that I have written so far, I can conclude. Instead of p of x, I replace this, I substitute this, ax squared plus bx plus c, plus instead of p of 1 over x, I substitute this expression, so it becomes a over x squared plus b over x plus c. On the right hand side, I have the same two expressions, this time being multiplied. So this becomes ax squared plus bx plus c multiplied by a over x squared plus b over x plus c. Usually, it's always better to get rid of fractions as soon as possible. So to get rid of fractions, you see I have these fractions here, and the highest power of x appearing in these fractions is x squared. So it is clear that if I multiply both sides of this equality by x squared, no fraction will be left. Okay, so I will multiply both sides by x squared, so I will multiply this. This term becomes ax to the 4. The next term becomes bx cubed. The next term becomes cx squared. But the next term, x squared, in the denominator will cancel that x squared that I am multiplying in, so it becomes a. The next term, one of this x will cancel one of the x's that I am multiplying. One x will survive, which will be multiplied to its numerator, and it becomes bx. And then if I multiply this by x squared, it becomes cx squared. On the right hand side, I have the product of these two. I am multiplying x squared in. That's up to me how to multiply. But if I want, for example, multiply it in the first pair of brackets, it doesn't do anything to the second pair, and still I will have fractions left. So this is why it will motivate me not to multiply x squared in the first pair of brackets, but in the second pair. So I will keep the content of the first pair of brackets the same, and then I multiply x squared here. When I multiply x squared here, that x squared in the denominator will cancel my x squared, and then it becomes a. The next one becomes bx because one of them is cancelled, one of them is left, and the next one becomes cx squared. Okay, and then what I do, I will try to write them a little bit simpler. So here, let me start with the highest power of x, ax to the 4, and it is alone. And then I have bx cubed, that is also alone, but cx squared appears here and there. If I add them, it becomes 2cx squared, and then I have a term bx, and finally I have the constant term a. But on the right hand side, I have to multiply these two second degree polynomials. So I multiply this each term of the left hand side, the left pair of brackets, to each term of the right hand side brackets, the content of the right hand side brackets. So this becomes a squared x squared, the next one becomes ab x cubed, the next one becomes ac x to the 4, and then I go to the next term here, bx, I multiply it here, it becomes abx. The next one becomes b squared x squared, the next one becomes b c x cubed. And then finally I will go and take the last term and multiply it on all of them. So this becomes ac plus bcx plus c squared x squared. On the left hand side there is nothing that I can do, so I just copy and paste it again, so this becomes this expression. But on the right hand side, let me also arrange this. So here you see that I have one term containing x to the 4, so let me write that one first. And then I have two terms containing x cubed, so let me factor x cubed out. From this one ab is left, from this one bc is left, and x cubed is outside now, plus how many terms with x squared I have? 3 of them. One is here, the second one is here, and the third one is there. So if I write this, I factor x squared out, a squared plus b squared plus c squared is left in the pair of brackets, and then I have an x squared out. And then if you see, you have this one which contains x, this one which contains x, nothing more. So I factor an x out, it becomes ab plus bc times x. And finally, there is one constant term here, and that is ac. So let me count the terms: 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 3 times 3 is 9. Okay. But this is mentioned that this relation, which is actually indeed this relation, is valid for all. So this all is very important for all non-zero real numbers x. This means that the polynomial on the left-hand side should be identical to the polynomial on the right-hand side. What does it mean? It means that the coefficients should be correspondingly equal. What does it mean? It means that if the coefficient of x4 on the left-hand side is a, and the coefficient of x4 on the right-hand side is ac, these two numbers should be equal. So this means that, so let me emphasize, for all non-zero x. So this sentence is crucial here, for all non-zero. Okay, so this means that this will imply that I have the coefficient a equals to ac, the coefficient of the x to the 3 is b on the left hand side, the coefficient of x to the 3 is ab plus bc, so they also should match. The coefficient of x squared on the left is 2c, the coefficient of x squared on the right is a squared plus b squared plus c squared. and then the coefficient of x on the left is b, the coefficient of x on the right is ab plus bc, the constant number on the left is a, the constant number on the right is ac. But if you look at these equations, two of them are redundant, yes? Oh, sorry. Two of them are redundant. This one is the repetition of the first one, so you don't need to care about the last one. And one to the last, this one, is also the repetition of the second one, so you don't need them. So how many equations are left? There are three equations left. And how many unknowns do I have to determine my polynomial px? Exactly 3, a, b, and c. So it means that in general I should be able to solve three equations for three unknowns a, b, and c and find them. Yes? Okay, so from here, for example, I move this ac to the left. So this implies that I have a minus ac is equal to 0. I can factor a out, it becomes 1 minus c equals to 0. Now the product of these two is equal to 0. Either the first one should be 0 or the second one, but a cannot be equal to 0 because it was assumed that a is not equal to 0. So this means that the second one is equal to 0, so this means c is equal to 1. Okay. Now that is, if we know that c is equal to 1, instead of this c I put 1. This means b is equal to ab plus b. But then I move this b to the left, it becomes minus b, so these b's will be cancelled. It means that ab is equal to 0. Again, the product of two numbers is equal to 0, and I know that the first one cannot be equal to 0, so this will imply that the second one has to be equal to 0. Okay, and then finally from this one, c is 1, so if I put c1 it becomes 2. On the right hand side I have a squared, and then instead of b I can put 0 to the 2, and then instead of c I can put 1 to the 2. But then what happens here? This is 2, 1 to the 2 is 1. If I move it to the left hand side, it means that a squared is 1. So there are two values for a. A is minus 1 or a is equal to 1. So there are two possible answers for a. But which one is the correct value? Both of them are actually correct, but there is also an extra condition in this problem that p minus 2 should be minus 3. So let me write it. So we have two sets of values. Either a is equal to 1, b is equal to 0, c is equal to 1. So this means that my polynomial px is equal to, if I put a equal to 1, so this becomes x squared, b is equal to 0, so this term vanishes, and c is equal to 1. So it means that either my polynomial is this polynomial, or if a is equal to minus 1, b is equal to 0, and c is equal to 1. So you see that for c and b we have only one possibility, but for a we have two possibilities. So what I need to do, I need to consider two cases. A equal to 1, b equal to 0, c equal to 1 means p of x is this. A equal to minus 1, b equal to 0, c equal to 1. This means that p of x is negative x squared plus 1. Yes? But which one satisfies this problem? Because you see that I have an extra condition here. But it is clear that this does not work, because if I calculate p minus 2 for this one, what happens? If I calculate p of minus 2 for this one, it becomes 4 plus 1, which is 5. But I have to have it equal to minus 3, so this will not work. But let me check this one. What is p of minus 2 in this case? What is p of minus 2 in this case? It becomes minus 2 to the 2 plus 1, which becomes minus 4 plus 1, which becomes minus 3, and that is exactly the number that it is mentioned in the problem. So finally it means that I found my polynomial. So this condition that was given here gave rise to two possibilities, either this one or that one. But then another condition that I had here from the beginning, using that we realized that actually the second answer is the correct answer. So finally this is my polynomial. Okay, now my goal is to calculate p of 2 plus p prime of 2, and that's easy. So let me calculate the derivative here for you first. So p prime of x becomes minus 2x. Now the question mark that I am going to answer is equal to p of 2 plus p prime of 2. Okay, p of 2 means you need to, instead of this x, I put 2, it becomes 2 to the 2, there is a negative sign behind that, and then plus. And then instead of p prime 2, I go here, I replace the x in the derivative by 2, so it becomes minus 2 times 2. And then I have to calculate this. So this becomes minus 4 plus 1 plus minus 4, so this becomes minus 7. And that is exactly the answer that we're supposed to reach to. I hope that this video was useful for you. I put the link for the PDF file of this paper. Until the next video, be safe and goodbye.